All right, let's dive right into this explainer. We're going to break down a pretty high-stakes, 6-mark SPM biology exam question today. But listen, we're not just reading off an answer sheet. We're going to transform these tiny, microscopic concepts into actual, real-world medical applications. Because if you've ever wondered how the cells in your body actually control what goes in and out, or how doctors know exactly what to put in an IV drip to literally save a life, well, you're absolutely in the right place.
So, take a look at this. We're looking at a totally authentic exam paper here. This is straight out of Chapter 3, focusing specifically on the structure and function of the plasma membrane. And look, we aren't just going to blindly memorize a marking scheme today, right? Instead, we're going to hack the exam by deeply understanding the biology behind it. Because, when you actually understand the mechanics of what's happening, getting the marks just naturally follows.
To keep things simple and lower the cognitive load, here's our roadmap for the explainer. First, we'll be tackling the exam question. Second, we'll look at the anatomy of the membrane. Third, we'll meet the semi-permeable bouncer. Fourth, we'll get into saline solutions and diarrhea. And finally, we'll wrap up with our final exam takeaways.
All right, let's kick things off with Section 1, tackling the exam question.
Okay, so looking closely at this diagram, Question 1A demands that we identify structures P and Q. Now, this whole visual represents the fluid mosaic model of the plasma membrane, and nailing down these two structures correctly, that sets up the foundation for literally everything that follows in this question. If you get this wrong, the application questions coming up become a whole lot harder to figure out.
Moving right along to Section 2, the anatomy of the membrane.
So looking at structure P, it's pointing straight to a glycoprotein. Notice how it looks almost like a little tree or maybe a tiny antenna just sticking out of the top of the membrane there. You can really think of this as the cell's own personal ID badge or its communication antenna. The exam paper specifically points out that P is formed from a carbohydrate chain attached to a protein molecule, and its main job? Cell recognition. That's exactly how your immune system knows which cells belong to you and which ones are foreign invaders trying to cause trouble.
Now, meanwhile, structure Q is pointing to the phospholipid bilayer. It's made up of these hydrophilic or, water-loving heads that point outward, and then hydrophobic, water-fearing tails that point inward. This double-layered boundary is absolutely essential. It's literally the structural framework that holds the whole cell together and completely separates the inside of the cell from the outside world.
So here's the best part. Just by taking a breath, calmly looking at the diagram, and identifying P as a glycoprotein for cell recognition, and Q as the phospholipid bilayer, boom! You've smoothly secured the first 3 marks of this 6-mark question. Seriously, half the battle is already won just by knowing your basic anatomical identification.
Okay, let's dive into Section 3, the semi-permeable bouncer. So, moving to Question 1B. It states that the plasma membrane has semi-permeable characteristics because it's built from layer Q and proteins. And then it asks us to state one characteristic of a substance that can actually move across layer Q. This forces us to ask a really practical question. What does it take to get past this VIP bouncer? Because let me tell you, the membrane doesn't just let anyone waltz right in. To score that full mark, the examiners want you to state the specific physical or chemical traits a molecule needs to get in. You only need to give one, but the accepted answers are the molecule must be small in size, nonpolar, or lipid-soluble. But why? Well, it's because the core of that phospholipid bilayer is made of those hydrophobic, water-fearing lipid tails. So large molecules or highly charged polar ones, they're getting rejected at the door. You've got to be small or lipid-soluble to just slip right through that tightly packed barrier. All right, shifting gears to Section 4, saline solutions and diarrhea.
So now we're zooming out from those microscopic bouncers to the whole human body. And this perfectly illustrates the real-world stakes in Question 1C. The exam asks literally, saline solution is a solution used to treat a diarrhea patient. Explain why. This right here is exactly where biology stops being just a drawing on a page and becomes a vital tool for human survival. To get these final 2 marks, you need to connect what you just learned about membrane permeability to fluid dynamics in the body.
Here's the step-by-step physiological sequence you need to lay out. First, severe diarrhea causes massive water loss. Because of that sudden drop, the patient's cells become severely dehydrated. To fix this, doctors introduce an isotonic saline solution directly into the bloodstream. And here's the magic word. Because it's isotonic, water is able to re-enter those thirsty cells safely, gradually restoring their normal function without causing any structural damage whatsoever.
Now, you're probably thinking, why not just give the patient an IV of pure water?
Well, pure water is a hypotonic solution. If doctors pumped that in, the water molecules would rush past our phospholipid bouncers way too fast. The dehydrated cells would swell up like balloons and undergo lysis, which means they would literally burst. No thanks. Saline is used because it's isotonic. Iso meaning equal. It perfectly balances that osmotic pressure, making sure the water moves back into the cells at a safe, highly controlled rate.
And that brings us to our final section, final exam takeaways.
Check out this summary table. It breaks down exactly how the examiners hand out those 6 points. You get 3 marks for identifying the anatomy and function of P and Q. You get 1 mark for knowing the entry rules of the phospholipid bouncer, and finally, 2 marks for applying the concept of isotonic saline to treat cellular dehydration. Honestly, this proves that understanding the real biological narrative, going from form to function right into real-world application, is absolutely the ultimate exam hack. I want you to remember this. The knowledge you're being tested on here, it isn't just some arbitrary textbook theory designed to stress you out before an exam. Not at all. It's the exact same foundational science that doctors and nurses are using every single day in emergency rooms all over the world to treat patients and save lives. So I'm going to leave you with this thought to chew on. The next time you're watching your favorite medical drama on TV, are you going to look at that simple everyday IV drip hanging next to the hospital bed and finally see those microscopic phospholipid bouncers hard at work? Keep that image in your head, and I promise you will never forget Chapter 3. Thanks so much for joining me for this explainer, and keep learning.